Perfect. Sounds good. Thank you so much for the introduction, Ron. And I know we have just a little bit of time together today, so I'm going to try to get through all this content as quickly as I can. But of course, as follow-ups, if anyone has any questions, definitely going to try to save some time at the end for Q&A. But of course, if there are follow-up questions from that as well, feel free to connect on LinkedIn, send me an email, whatever works best. But really quickly, to just introduce myself to you all, my name is Meha, and I am a cloud solution architect here at Microsoft, focusing on AI and machine learning workloads with our customers. So in my day-to-day, I work with a bunch of different customer teams, helping them design their orchestrators, build out their AI applications, design their secure landing zones, and really getting them set from the idea of POC for a GenAI application and taking that all the way to production. So really quickly, just before we hop into the fun stuff around GenAI, just wanted to take a step back and just come in with a reminder that while there is a lot of excitement in the generative AI space, there is still a lot to the AI machine learning platform when we talk about what really is AI in Azure. And today, we don't need to go through every single service and every single feature we have available in Azure, but just a couple of things that I want to highlight over here. And starting with the main idea that when you are building generative AI applications, typically this will not be done in a silo. Oftentimes, there might be a need for a complementary model, such as, for example, language translation. There may be a need to crack documents and extract content from your documents before you perform any sort of analysis and use generative AI to get insights. So while generative AI is one aspect of that story, there are a lot of tools within Azure, all the way from allowing you to train your own homegrown models, build your own custom models, you training on your own data sets, all the way to pre-trained models that serve specific functions, such as I mentioned, like language translation, document intelligence to crack your documents, that are already available for you to be able to use off the shelf. So as you start to think about what that Gen AI application looks like, you already have so many of these tools ready to use off the shelf and build that full end-to-end story that is needed for a production grade application. Now, just to clarify a little bit as well in terms of what OpenAI looks like on Azure, on the Microsoft Cloud Platform versus OpenAI on its own. So main takeaways over here are that Microsoft has made a commitment, a partnership with OpenAI that as OpenAI develops their models, those models are going to be coming to the Azure cloud ready for teams to use. Since these models are already available in the Azure environment, you are able to treat these models as any other service that you have deployed in the cloud. You are able to apply the same best practices, such as role-based access control. You are able to maintain, for example, which regions you prefer for your deployments. You are able to have continuous monitoring and integrate that with your existing applications. You are able to incorporate private endpoints. Now, great thing about these models as well is all these models for OpenAI are token-based usage, token-based cost. So same way you're charged for any other resources, same billing system. So super easy, just incorporating that into an existing flow. These models also allow for fine tuning. So should that be a need for your specific use case, you are able to do that. And last but not least, Microsoft on its own is also doing a lot of stuff for content filtering and all of that, just to bring those additional layers of safety to those models when you deploy them in your environment. And I think just in the last year or two, seems like there are new fun announcements every single week of what's the latest and greatest. And quite frankly, oftentimes, sometimes just hard to keep up. There's something new every single day. And with that level of excitement and innovation at a pace that we've really never seen before, I just think security is more important than ever, just because we really want to make sure that as we are deploying these models, as we are building these generative applications, as we're really doing AI in a way that we have never done before, we want to make sure that what we are putting out for our customers, our internal teammates, is giving us the content that we expected to give and making sure that we are taking the time to ensure that we are putting not only just those traditional security controls of just like private endpoints, access, all of that stuff, but also really understanding the type of content that our models are putting out so that based off of the type of use case that we are trying to solve, we can make sure that these models are answering our questions and telling the story in a way that we would like for it to be presented. So, with that being said, wanted to take a quick poll from the audience. So, who has heard of the concept of AI hallucinations before?
Well, I have. I see a couple of hands going up. You can put the comments in the chat. Yeah, a lot of thumbs up coming up here.
Nice. So, one of my favorite images to show around the concept of AI hallucinations is this one. And I feel like we all have gotten some of these, like when we're logging into systems, those different like questions that we get asked from the system, like select all the squares that have bicycles, select and this is a very funny one, I think. So whether or not the image is showing a chihuahua or blueberry muffin. And this is a pretty funny comparison because even I had to look at a couple of these a few times just to be sure about what I was looking at. But in theory, if you had to think about what would you, looking at these pictures, how would you actually differentiate what the chihuahua is and what the blueberry is using words? So we, of course, as humans, know what a chihuahua is, what a muffin is. If we look at the image for a couple of seconds, we're able to tell very closely, okay, like we know what it is. But to explain those rules now to a system, that's where things get tricky. Like in these pictures, really, what is the differentiating point that you would give? Especially, so for example, like in a lot of these images with the chihuahuas, like you can't really see the ears. Both of them have those like blue, black spots on them. It's hard to really just put into words what those differentiating points could be. And that is really where some of those similar visual characteristics can cause challenges because the way AI systems learn is using patterns based off of shapes and sizes, and AI isn't really able to understand some of those nuances just the way humans can. So, with that being said, something I really wanted to take the time to just take a step back on. So, is that while these large language models really are able to give us a lot of benefits, it's always important to remember that they are not flawless. And understanding the limitations of these models is crucial just as appreciating their strengths is. And like I said a couple of minutes ago, this field is evolving quicker than ever. So there are a lot of different things that may not be that are true today that may not be a limitation tomorrow. But as these systems continue to evolve, it's really important to understand what the current limitations are today. So we are designing using some of those best practices in mind. So all in all, so AI hallucinations in LLMs really occur due to the system's reliance on pattern recognition. So the way that humans, once again, comprehend information is not the same exact way that LLMs understand information. They do not have that same level of comprehension. The way LLMs generate output is based off of patterns. So based off of the patterns of what words it's seen together, it will predict the next word based off of patterns rather than that cognitive understanding that humans possess. Then LLMs were also just trained on a very large corpus of information. So sometimes the interpretations that it can make may not align directly with the input given. And this is where a lot of the work that we do around prompt engineering, around grounding with our own data really comes into play. Um, and a great example I like to give of this is just words with multiple meanings, for example. So if you take the word capital for example, what that can mean a lot of things to someone who maybe studies geography. Capital might refer to state capitals, country capitals. For for folks that are more in the grammar space, English majors, maybe they think about capital letters. For those in the financial space, just thinking about capital, like very, very same word, multiple different meanings. And as a result of being trained on patterns, there can be multiple interpretations. So we really want to make sure that we ground these models, give the information so that it doesn't hallucinate. And something I'd like to note about hallucinations is a hallucination general doesn't always mean that information is incorrect. It could very well mean that the information is correct, but it just does not fit the context given. And that's really important to note as well, because that is where I think there are two different sides of that challenge that we want to try and approach. And last but not least, as well, with these large language models, we know that they aren't always continuously training. So, for example, like I know some of the GPT-4 models, those were trained like up until 2023. So there are things that these models were trained on that may not be true anymore. So with that being said, they might have been true at the time, not true anymore. So we want to make sure that as we develop these applications, we're also keeping those things in mind, and whether or not we ground it to like a Bing search index API and be able to do those comparisons for anything that might need real-time data. So cross-checking for up-to-date data is also a very helpful tool to be able to avoid some of those hallucinations, because once again, hallucination doesn't always mean incorrect content. The content might have been correct at a time, but due to changes just in the world, it might not be correct anymore and therefore considered a hallucination. So how can we control and evaluate the output of our AI? So this is where we can use a bunch of different specialized tools. So wanted to give a high level of the slide, and there's a lot going on over here, but really what I wanted to include just as a high level before we dive into some specifics is in Azure right now, there is a lot going on in the back end as well in terms of just responsible AI as well. And in that space, making sure that based off of the input that a user provides, if something is flagged as harmful content, whether it's hate, whether it is PII, that the system automatically just flags that and doesn't even try to create an answer based off of some of those things. So in our OpenAI tools, if you try to ask like a certain type of question and it is flagged as some sort of safety breach, it'll automatically flag that and not even return that response. But there is a lot going on in the slide, and unfortunately, we don't have time to look at every single step going on over here. But really, what I wanted to highlight is that with the state that generative AI is in today, and even though things are growing at an incredible pace, there is still going to be the need for human review in the process. There's still going to be a need for your SMEs on whichever product you're trying to build, whichever type of maybe chatbot you're trying to build on your data, those SMEs are still going to be very, very crucial to what we build and reviewing the content that the LLM is putting out to avoid that idea of hallucinations. So as you build your design teams internally, you'll have your data scientists, you'll have your software engineers, you may have your secure infrastructure teams. Those humans that are SMEs on the data that you're trying to answer questions on are still going to be very, very critical to this equation. And a great way to build orchestrators in Azure, which you may or may not have used before, and a great way to evaluate your content output as well is using this tool called PromptFlow. So PromptFlow is a tool available through both our traditional machine learning service as well as our AI Studio tool. And the goal of this tool is to really help streamline the process of the entire development cycle of your AI application. So in the simplest words, I like to explain PromptFlow as a very easy way to build the backend orchestrator for your application that can then easily be deployed as a API endpoint and then consumed from any sort of solution that you may be interested in. So within PromptFlow, we have a lot of tools to be able to not only connect to just your large language models, but also any sort of internal or external data sources you may want to ground the model with, and any sort of tools or custom code to enhance your orchestrator to be able to answer more complex questions, work on some of those more complex use cases. Then within PromptFlow itself, we have a bunch of different tools for evaluation and being able to compare the LLM's answer to answers that have been provided by a SME at your organization that really understands the data well, and understanding how comparable is the LLM answer to how your technical SME, your product SME may have answered the question. And lastly, within PromptFlow as well, there are a bunch of different tools to be able to easily tune your prompt, create multiple versions so that you can easily test out multiple versions of a prompt with slight similarities, slight differences, and really be able to see how some of those changes in just a few words can potentially make a big impact in terms of how this tool has presented or how your LLM has generated the answer. So high-level diagram over here in terms of what that development cycle looks like. So things initially start with just that design process. So starting to build out your prompt, starting to incorporate your groundedness with any sort of internal data sets that you may be bringing in, any sort of external data sets or real-time data connection points that may be necessary for your application. Then comes that second step of evaluation. So in complement to that flow that you're treating as your orchestrator, you can build a parallel evaluation flow at the click of a button that will compare your SME's output, your SME's answer to a question in comparison to what the LLM is generating. So for example, you can have your SME, let's say, create a list of 20, 100, 1,000 questions and provide their answers, and it will one by run those questions quickly through your orchestrator and give you a score between what the SME answered the question with and what the LLM answered the question with. And based off of that, it will assign a score from 0 to 1 based off of similarity. So the algorithm that it's using to be able to generate that score is cosine similarity. And basically, it just looks at those two output answers, turns them into a vector as well, and then does that comparison of the two answers. And the higher the number, the more close in results the two scores are. So that is a great way of understanding how well your orchestrator, your LLM, is answering the questions in comparison to your SME. And then based off of those answers, understanding where in that orchestration flow may you need to make certain changes. So for example, two answers in sentiment could be exactly the same, but the tone used by your SME versus the LLM could be slightly different. Then that gives you an idea saying, okay, I need to go back to my prompt engineering if we're trying to mimic the tone of the SME, for example. So a lot of great insights that can be found using this tool and very, very easy to set up in the environment as well. And then lastly, once you have an orchestrator that you like, super easy to then go ahead, deploy that as an API, and then really easy to have that set up and hook that up to your applications. And of course, just like anything else, this is not going to be a one and done exercise. As you start getting user feedback, your application will grow. You may want to make changes to your orchestrator. So a lot of opportunity for continuous optimization here as well. And it really provides you that tool belt needed to continuously improve based off of evaluation metrics that you are able to gather. So I know we're almost at time, but really last things that I had here, just really just a quick slide on how cosine similarity work. So just takes your text, runs it through an embedding model, creates a vector, and then for both your SME's answer as well as the LLM's answer, it will compare both of those together and give you that score between 0 to 1 based off of how comparable the two answers were. With that, I know we just have a minute or two, so Ron, I don't know if we have time for any quick questions or if we need to hop to the next speaker, but just wanted to say thank you all for joining today. And like I shared in the beginning of my talk, if anyone would like to connect on LinkedIn or send an email with any questions as well, more than happy to help you out where I can.